In this video, we're going to do a basic setup on the Tron Gemini. So we're going to select a brand new model and then we're going to fill in all the details in the basic setup and then we're going to go out and fly it. Now before we do anything, we need to take the blades off. So on the tail, I'm running some Azure 95mm tail blades. And then for the main blades, I'm running some Azure 560s. For the flight controller, I'm using a brand new VBar EVO. I'm also running a first buffer pack, although I am intending to replace it with one of these, which is the VBar Control Power Backup. For servos, I'm running a Theta THM 982 on the tail. And then on the Cyclics, I'm running some GDW G50 servos. So these are mini servos on the tail and the Cyclic. The speed controller I'm using is a HobbyWing Platinum 150 V5. So this will do 150 amps and peak at 180 amps. And it's also designed for 3S to 8S. And we're going to be using it on 6S. And the motor is an egodrift 4025HS 1050 kV. And this has been working really well. And for connectors, I'm using AS150. So these are anti-spark connectors. However, I'm not actually using the anti-spark because the HobbyWing has its own anti-spark built in. So before we start plugging anything in, we need to set the servo arm length and we need to set the centering on the servos. Now normally you can find the servo arm length in the manual. So if we go to the Tron website and then go into the manual section and down to the Orion Gemini manual and we search for servo horn, you'll see here that we have the cyclic servo horn. So this is saying 15 to 16 millimeters. If we go and look for the tail says 15 millimeters. Now I generally use these Theta heavy-duty servo arms on all of the Tron helicopters I use. Now that we know the servo arms are the right length, I'm going to use this servo tester to set the centers on each of the servos. So the servo tester will allow me to test the servo like this, but it also has a center position. So that's now locked in the center. So this means we can now try and get the best position for this servo arm, so as close to center as possible, which I think is about there. So those are all the servo arms set to length and centered, which means now we can start powering it up. So now it's time to power up and put power into the receiver. Now the first thing I'm going to do is I'm going to make sure that all the leads are unplugged from the VBar EVO. So now when we put the battery in and then we apply power, because there's no leads plugged into the receiver won't actually power up. So we're going to take that power lead from the back and we're going to plug it into the first port. And you can see it powers up, asks us for a battery. Now if we go down to model setup and choose a brand new model setup, we're going to choose other and then other 600. What it'll do is it'll reset that Neo or Evo, send all the default data, and now you have to start by changing the name. So we're in the basic setup menu. We're going to change the name. I always give it a number at the end of it because it kind of irritates me if there's no number when you start model 2. So the sensor orientation, so when they say orientation wire rear or wire front, they mean the wire for the servo leads. So this one is going to have wire rear. It's defaulted to a clockwise rotation on the main rotor, so we're going to leave that. Now it's asking for the servo type on the swash. And they give you quite a few options here. So what we're going to do is we're just going to go and look up the specs for the GDW G50 servos. And we can see here that Copilot is telling us that it's 1520 by 333 Hertz. So we choose that from the menu. And it's as easy as that. So now if we go down to the swash plate type. So the swash plate we have is a single rear servo and then 2 servos on the front, which is an HR3. Now they have lots of other settings and layouts for servos, but we're just going to choose that 120 degree reversed. So it just sets the some of the values. Now on the diagram you can see servo 1 is the rear one at the bottom, and then servo 2 and then it goes clockwise from there. So servo 2 and 3 are the left and the right servos. So now you can see if I plug in a servo to channel 1 and then I move the collective stick, you can see that the left and right servo moved, whereas it should have been the rear one. Whereas now if we plug in the third servo lead and we wiggle it, we can see that's now in the right port. So this should be servo 2, which it is. And then the final servo is servo 3, which should be the one on the right. So you can see the one on the right is now moving. So you can see it also moved incorrectly. So if I move the collective stick up, you can see the rear servo was actually going down. So I'm going to reverse channel 1, and now you can see they all go up. And then if I test the cyclic, it goes left and right exactly as it should. So with the servo tester, we got the horns as close as possible to 90 degrees. So what we're going to do now is in the servo trim, we're actually going to trim it so that it is true 90 degrees. And when I say 90 degrees, so we want the servo arm 90 degrees in relation to the push rod. Now we're just going to trim each of the channels individually. And that looks pretty good. So now we're going to come to do the pitch, and so the first thing we're going to do is we're going to calibrate the pitch gauge. So we do that by putting it on the motor, and the reason is that the model might not be level on the table. There we go. So that's now calibrated to the model, and then if we now put that on the blade, you can see that is just about at 0 degrees. So in mid stick we got 0. So let's go and do the pitch first. So it defaults to 100, and at the top we have 13.5, and at the bottom we have 12.4. So we're just going to increase the lower one to give us 13.5 again. .5, there we go. So 13.5 on the bottom and 13.5 on the top. So that is perfect. So now we can do the calibration. So this is your cyclic calibration. So the fly-barless system needs to know where 8 degrees is on the blades, and it does that so it can optimize how it flies. So it's currently at 0. We hit the check mark. That now goes to 9 degrees. Now we're looking for 8 degrees, so we're just going to reduce that. 8.5. Right, so let's just go out of that. So back to 0. No, that's gone too far. Let's just... So back to 0. 8. No, we're going to go a little bit higher. There we go, exactly 8, so that's perfect. Right, so let's do the tail setup. So we know that servo is a 333 Hertz, 760. Right, so let's just check the direction. Now the direction isn't hugely important at this point because we can actually go and we are actually going to do a pre-flight check at the field, so we're going to change that. But the defaults, the limits are defaulted to 40. So if we just start increasing that, and that's about as far as it'll go on that side. And then we'll increase that as well. And that's about there. So So that looks about perfect. And these numbers are actually very close to each other and also very close to 100, which is what you want for the VBar to work at its optimum. Let's just go down to governor setup. So I'm going to leave the governor output speed at its default. Now it's currently got VBar electric gov, but I'm going to change that to the HobbyWing gov. And the reason is that it's just a lot simpler initially, because what will happen then is it just outputs a set throttle percentage, and then the HobbyWing gov will just use that percentage. Whereas if you set up the VBar gov, there's a lot of extra parameters that you need to do, and there's a whole procedure that you have to follow. So the output setup we're going to leave as default, and the gear ratio we're going to change to 8.5. Oops. And it is a 10-pole motor. And the range, max 4,800. So this was added sort of fairly recently in the last couple of years, and it's mostly because that's smaller models require higher RPM, so they now give you an option of what your max RPM is, but we'll leave that at 4.8 because we're not going to go over that. And that should be the default setup. So the only other thing I'm going to do is under telemetry, I'm going to set my voltage monitor to 7 volts. And the reason for that is it's got a buffer pack, and if it starts using the buffer pack, let's say the input voltage dies or the battery gets unplugged in flight and we have no BEC, this voltage will start dropping as it's running on the buffer pack, and then as soon as it goes below 7 volt, then I'll get a warning. So that's the one I set every single time. But that is it. Now we're ready to go. In terms of the flight settings, we're actually not going to change much. We're going to leave that for a later video. So for now, we're going to change the default screen. So I use a HobbyWing ESC on this model. So I'm going to set my default screens for bank 1, 2, and 3 to use the HobbyWing screen that I've set up. And you can see that this has now got all my voltages that I want. I've got rid of the helicopter logo, and I've got the RPM as well as the flight time. Now for the flight settings, what I'm going to do is I'm going to choose one of the presets. So we have basic setup for sport flying, for normal flying, and for pro 3D flying. Now I'm just going to choose 3D pro flying. Now what this does is it just sets up your flight parameters in a way to suit your style. So if you're just learning to hover, you're going to choose the first one. And if you're doing sport 3D, you're going to choose the second one. And then if you just want decent performance, you're going to choose the third one, which is pro. And you can see the values here. So for the agility, we've got 90 to 120. The gains are all set to 72. And then if you look at the tail defaults as well, we've got a similar sort of thing. Rotation rates of over 100. And at any point, we can go back to the reset tools and we can just say, reset all of our flight parameters. And it won't change any of those basic settings that we've already changed and set, like the pitch. So now it's ready to take to the field. So one of the first things you want to do when you get to the field after a rebuild or on a maiden is to actually make sure that all your links are on the balls and you haven't forgotten any screws and bolts. So what I tend to do is if you try and pull the servo horns off the servo, and if you try and give the links and the ball links a bit of a tug just to make sure that they're actually on properly, so we don't have any loose bits there. And we'll do the same on the tail. And we'll just give that a little pull. Give that a little pull as well. Right. So there's nothing hanging off, which means we can now go on to the blades off test. And we're going to spool it up, and we're going to test all of the head speeds, and we're going to test that the fail-safe and also your bailout is being set, and rescue as well if you use rescue. And then we'll just make sure all the switches work in the way that we would expect them to work. We don't want to get any surprises on the flight line when we've got the blades on. So first we'll check the directions. So I'm just going to make sure the swash plate goes left, right, forwards, backwards, up, down, and that the tail goes left and right. And then you want to check your compensations. So if you just take the model, So the swash plate reacts by going in the opposite direction, which is fine, and the tail is also reacting by going in the opposite direction. And one thing that tends to catch people out sometimes is that you can have the tail going the right way, but if the belt is wrong, it's going to go the wrong way. So do a turn, make sure the belt's going the right way. All right, so it all looks...
Head speed 0, current 0, output 0.
It all looks ready to go. So I'm going to put it into bank 1 and spool it up. So that's actually bank 2. Bank 1 defaults to 40%, so which means the ESC is not actually ticking over. So I'm going to raise those defaults. So if we go into governor and we set, let's say, bank 1 to 60, bank 2 to 70, and bank 3 to 80. And we'll just see what head speed does give us. Right, so bank 1 is 1,800. Bank 2 is 2,200 almost. And 2,500 in bank 3. So those look okay, we can probably fly with those. And now what I'm going to do is I'm just going to move the sticks around and make sure it doesn't do anything weird. There's no binding. There's no strange noises. One thing you can also do is you can go into the status and check your vibration levels. Now these will generally be quite low because you don't have any blades on, but it is useful. So look, so there's practically nothing showing, which is pretty much what we expect. We can test the bailout. So bailout is not working. So for that, we're going to have to just raise the bailout auto rotation value. So it defaults to 15. Let's just change it up to 40. Right, bank 1, bank 2, auto rotation, bailout. You can see the bailout's super quick on that one. But that should be good enough. So now it kind of works as we expected. I don't see anything weird. We can spin it over for a bit. There's no strange noises. And the only other thing I generally set is the telemetry readouts. So I use telemetry readouts. So one of them I like to have head speed
2,189, current 8, output 65.
So there we have head speed, current, and throttle output. So that's the throttle output from the ESC. And I like to use that for debugging purposes because it'll tell you how much headroom you've got left over. And then if I push the switch the other way,
battery 85%.
It'll tell me the battery percentage. So that I can use at any
battery
point during the flight.
85%. Head speed 2,139, current
that,
8, output 66.
Thank you. But that all looks pretty good. So we're going to get the blades on and then we're going to go fly it. Okay, so we've done the blades off test, we've checked all the links, we know that it's not going to fall apart, so now we're going to fly it, and I'm going to double check the gyro directions and the control directions again, because you'll be surprised how many times you'll catch something on the second time around. So we'll do swash forwards, backwards, left, right, pitch up, pitch down. We'll check the blade, the tail blade, so that is right and that is left. Then we'll check the gyro compensation directions. So if we tilt the model back, the swash should tilt forward. If we tilt the model forward, the swash go back. Same with left and right. And with the tail, if we go that way, it compensates by trying to go the other way, which is correct. And then the last check was the belt direction. So the belt is pushing the tail in the right direction. Right, let's do here. So we'll start with a bank 1 spool up. So that's 1,550. We'll just check vibration levels. So model status, vibration levels. Right, so that's 100, so that's only even slightly higher with the blades off. I'll try bank 2. 200 vibration. And bank 3, amazing, back down to 100. So vibration level is extremely low. And that's on the ground, where you could actually get some sort of ground resonance as well. And then I just want to check the peaks. So now I'm just looking at the screen that shows me the peaks for tail, motor and main blades. Right. And none of them is peaking higher. They're all peaking about the same level, so very low. So I think in terms of vibration, we've actually definitely, there's no problem there at all. Okay, so even with that basic setup, that only took us a couple of minutes, we've actually got a model that can fly circuits. We can even do stall turns. It'll even go upside down. The tracking looks pretty good. Okay. So the only thing we haven't done is set the gain. So if you look at the tail stops, it does drift a little bit. So the tail is definitely not as good as it could be, but we'll cover that in the next section. And let's do a little auto. Right, so we did a basic setup and we chose the Pro settings, and it's actually completely flyable. So in the next video, we're going to go through all of the flight settings. So we'll tune the tail a bit, we'll tune the head gain, and we'll go into some of the advanced tuning features as well. Until next time.